Welcome to Daily Papers. Today we're tackling one of the biggest questions in technology and maybe even philosophy. How can we be sure that a super intelligent AI is truly on our side?
It's the central problem of AI safety. We want to make sure AI systems reliably do what we intend them to do. But how do you check that? You can run tests, sure, but that only shows how it behaves in those specific situations. What about the situations you never thought to test?
Exactly. It's the difference between seeing evidence that something works and having a mathematical proof that it will always work. And a new paper called On the Formal Limits of Alignment Verification by Ayushi Agarwal explores this very idea. It asks, could we even in principle create a procedure to formally certify that an AI is aligned?
The paper argues that any ideal AI safety certificate would need three key properties, and this is where it gets really interesting. Let's call them the three guarantees.
Okay, what's the first one?
The first is soundness. This is the no lies guarantee. It means the certificate is reliable. If the verification procedure gives an AI a passing grade, you can be certain that the AI is genuinely aligned. It will never certify a misaligned system. No false positives.
That makes sense. A safety certificate that sometimes lies is worse than useless. It's dangerous. What's the second property?
The second is generality. This is the ready for anything guarantee. It means the certificate isn't just valid for the test questions we gave the AI. It holds true for the entire universe of possible inputs and situations the AI could ever encounter, in the wild, in the real world, facing problems no human has ever seen before.
So it's not just safe in the lab, it's guaranteed to be safe everywhere, forever. A universal guarantee. What's the third and final property?
The third is tractability. This is the actually doable guarantee. It just means that you can actually run the verification process in a reasonable amount of time. It doesn't take a supercomputer a billion years to finish. It's a check you can practically perform.
Okay, so to recap, we want a verification method that is sound, so it's reliable and never wrong, general, so it covers all possible situations, and tractable, so we can actually do it. That seems like the absolute minimum for a real guarantee.
It does. But here's the bombshell from the paper. You can't have all three. It's a trilemma. You can pick any two, but you will always have to give up the third.
Wait, really? You can have any two but never all three? Let's walk through that. What happens if we pick soundness and generality, so we have a perfectly reliable check that covers every possible situation?
If you have that, the paper shows you have to give up tractability. Your perfect universal safety check would be so computationally complex that it would take an impossibly long time to run. For some of the most powerful AI models, the problem is what's called undecidable, meaning it's literally impossible to solve no matter how much time you have. It's like having a blueprint for a perfect machine, but it requires a type of metal that doesn't exist. The guarantee is perfect in theory, but you can never actually get it.
Okay, so that's not very useful. What about another pair? Let's say we want our check to be sound and tractable. It's reliable and it's fast. What do we lose?
You lose generality. You can have a reliable and fast check, but only for a limited, bounded set of inputs. You can prove an AI is safe when dealing with, say, all questions about chemistry, but you have no guarantee what it will do when someone asks it about poetry or military strategy, or a problem no one has conceived of yet. It's certified for a specific domain, but its behavior outside that box is a total unknown.
So you have a guarantee, but it's a very narrow one that might not cover the most dangerous, unexpected scenarios. Okay, last combination. What if we have a check that is general and tractable? It's fast and it applies to every situation.
Then you have to give up soundness. Your verifier isn't perfectly reliable. It might give a passing grade to an AI that is secretly misaligned. And the paper explains why this happens. A fast check can only look at a finite amount of evidence, but an AI can be built to behave perfectly on every test you throw at it, while still having a different internal goal. It's like an actor playing a role. It looks and sounds just like the real thing, but its true intentions are hidden. The verifier sees the same good behavior and gives it a pass, not realizing one system is genuinely good and the other is just a very convincing imposter.
And that's terrifying because the imposter AI is the one that might do something completely unexpected and dangerous when faced with a new situation. So why is this trilemma a fundamental limit?
The paper points to a few deep reasons. One is that just looking at an AI's behavior, its outputs, doesn't tell you for sure what its internal goals are. Two different AIs can be programmed completely differently inside, with different motivations, but still give identical answers on all your tests. A verifier that only looks at behavior can't tell them apart.
So is this paper just bad news? Is alignment hopeless?
Not at all. This is the most important part. The paper isn't saying we're doomed, it's giving us a map of the problem. It shows us the hard limits and tells us exactly what trade-offs we're making with our current safety techniques.
So instead of searching for one single perfect guarantee that can't exist, we should be thinking differently.
Exactly. We should be thinking in terms of structured risk management or defense in depth. Maybe we use a fast but slightly unsound method to catch 99% of problems. Then we use a slow, sound method to verify the most critical parts of the AI's code. And we combine that with interpretability tools that try to peek inside the AI's mind to understand its goals.
So no single tool can satisfy all three conditions, but by layering different tools that make different trade-offs, we can build a system that is much, much safer, even if it doesn't come with a single, perfect certificate.
Precisely. The trilemma isn't a stop sign, it's a guide. It clarifies the challenges and points researchers towards the most promising directions. It tells us that when someone claims their AI is 99% aligned, we need to ask, what guarantee did you give up to make that claim? Was it soundness, generality, or tractability?
It's a powerful framework for thinking more clearly about one of the most important challenges of our time. This paper doesn't solve AI alignment, but it draws the boundaries of the puzzle, showing us its true shape and size.